I'm Stephen Foskett, organizer of Tech Field Day, and we are here at Storage Field Day in Santa Clara, November 2022. And we are taking a look at the blast radius that's caused by ever-increasing systems. That's right, everything seems to be getting bigger, whether it's the number of CPU cores, the amount of RAM, the amount of storage, the size of all of these devices. Everything just keeps getting bigger and bigger and bigger. And if that happens, then of course the impact of any failure is bigger as well. And so we have to start thinking about those sort of things. You know, what happens if there's a component failure? So David, this was your suggestion. Tell us, what do you think about minimizing the blast radius?
It's a fascinating topic. And in my world, I work in the relational database world. So we have to deal with storage failure. One of the topics yesterday was RAID rebuild times on these massive drives, terabytes per minute or 10 minutes or whatever the metric was. We have to deal with that. Then we have to deal with switch failure. Then we have to deal with concentration on a host. And then we have to deal with operating system failure and database failure and all this other stuff. How do we handle this as these things just get bigger and bigger and bigger? And part of it's distributed systems, part of it's redundancy in the platform itself. So that way, if there's a fault, you get an email. But as these things get more complicated, what do we do?
Well, I think that one of the, misconception about, the blast radius, we always had problem. Even when the hard drive was 2 megabytes. So, at that time, rebuilding 2 megabyte hard drives was a problem, and backups and everything. And now you have this 20 terabyte, 30 terabyte, weird today of a 60 terabyte hard drive. But actually, everything is balanced at some point. You have hundreds of core in a server. You have terabytes of RAM now because CXL, everything will become even bigger. So, and we are not really dealing with the 2 terabyte anymore. We are dealing with petabytes. Think about analytics, AI, and everything. So everything gets bigger. So when we say, we were used to say, the terabytes is the new gigabyte. The same is now. So the petabytes is the new gigabyte, the new terabyte, whatever you want it to be. So I don't think it's a big problem. The problem maybe is a little bit different because how fast can you rebuild? The blast radius is linearly similar. So 10 years ago was 1 terabyte. Now it is 1 petabyte, maybe 30 terabyte or whatever it is. So and you grow all the system in the same way. But actually, are we able to write and move data as quickly as we need to have minutes to go back in the best scenario? That's probably way more difficult than just thinking about a single component that fails.
So it's interesting that the one of the answers to the blast radius problem is really the upfront architecture of the entire system. So back when we had the small drives talking about, right? The way we got that production system back up was restoring from some sort of a tape media, right? So we didn't have a secondary site except for those tier 0 applications, right? Where we do the synchronous replication or even asynchronous replication, right? Where we'd have another system up for only a small set of those systems. But the problem is that now that you can't back up a multi-petabyte system to tape and expect it to be back. You have to have a replica of that data somewhere else, which means that now the cost, both from a financial perspective as well as from an ecology and sustainability perspective, that cost is going to be 2x or perhaps even 3x, depending on what kind of a failure scenario you can accept. So like if you lose a region's array that has 30 petabytes in it, okay, well, I've got to have another 30 petabytes that's going to be somewhere else that I'll replicate on a regular basis incrementally. But then knowing how long it's going to take to recover that first 30 terabytes, do I do an N+1 situation where, because I can't be in that situation where I only have one copy of that data now. So it lends itself to these architectures up front that you're spending a lot more money and on hardware and services just to deal with the blast radius issue, because you can't get back a production system the way you used to. And so it's changing kind of the cost dynamics and all this stuff. So every bit is really costing you 3 bits or 2 bits in everything you do. This is something from an infrastructure perspective. Keep in mind also getting that data and recovering that data into and rebuilding that stuff. If you have to bring it from one site to another, the networks, the interconnection is not kept up from a speed increase as the density has increased and the data density increases in these sites.
I think that the value of data has changed. I mean, so the valued over time. I mean, so 20 years ago, you had the time to recover everything. Nobody was connected all the time, even a bank. Do you remember? I mean, 20, 30 years ago, you were going to a bank, and the counter, they said to you, oh, no, we don't have the connection this morning. We can do some operations, but not everything. And you say, okay, it's not a problem. Now you have your phone. You are connected 24/7. And if something goes wrong, you start to blame on social media your bank because you don't get the best service of the world. So so the problem has a different scale. So we were accepting different kind of service levels.
Yeah, I'm not even just talking about production service levels. I'm saying, if you had to rebuild a 30 petabyte or more as it gets bigger data set, the time it would take to do that is so long.
And
right? As Dave was talking about.
I don't think that's necessarily true, because the networks have increased quite a bit in terms of time as well. The drives that we were talking about with Solidigm just a few minutes ago, these were 60 petabyte drives capable of 1 million IOP reads. If you say those are 16K reads, you can actually evacuate that entire drive in about an hour. And if you go with a system sort of like the Power Max or whatever, or like a solid fire type architecture where you're actually spreading the data out when you evacuate it, if you actually are sending it to 10 different drives as you evacuate it to redistribute the data, you should be able to actually do that in about an hour.
Well, I
and
think
then the other factor is the networks in between that you need to have going on them. But there are 100 gigabyte network now, and typically if you're going to be buying 60 petabyte drives, chances are you're going to have a 100 gigabit network.
Yeah, but the blast radius point, okay, in the past when you could have this array spread across, say, 4 or 5 racks, now you got this stuff in a single 2U array. You lose the rack, you're done.
Well, it's just way bigger. Yeah. And when you talk about blast radius, so I don't want to give the wrong impression. I mean, so disaster recovery is a thing. I mean, so if you have to recover 30 petabytes, probably you are in a disaster recovery scenario.
Correct.
Like if you're, if you have a server or a single drive that has a failure, okay, you want to recover just that component. So I totally agree with you that make copies of 30 petabytes, keeping synchronized and everything is complicated. It will be always complicated because you start talking about long distances, so latencies, and et cetera, et cetera, et cetera. So not just bandwidth, but when you talk about the blast radius, we are talking about servers that now can host 1 petabyte in 2 rack units, probably more. And so this is huge. I mean, for me, it's still huge. Maybe for Facebook, it's not. But for me, looking at the 2U servers and think, okay, there are 2 petabyte there. I mean, for me, it's a lot. So that's a problem. That's the real problem today. So how quickly can we recover from that? Because it's not.
So Power Max, I think it was yesterday, talked about they were able to rebuild a terabyte in like 10 minutes or something like that. So yeah, a 60 terabyte drive is going to take, a long time, but.
Well, a 60 petabyte drive would take 60,000 times.
60 petabytes would be.
That's still fairly large.
Times that.
Yeah.
So, but I want to kind of level set here. One of the things we have to deal with, and I think that somebody brought it up a minute ago, is this whole idea of sort of inflation of data. So just like when you talk about you're comparing the cost of things, you have to compare them in adjusted dollars, because you have to think about buying power and all that sort of thing. We also have to think about, I guess, adjusted data, because what's big? Is a 60 terabyte drive big? Is it bigger than a 60 gigabyte or a 60 megabyte drive? That sounds stupid, but think about that. In 1994, an 80 megabyte hard drive was a normal hard drive size, right? In 2024, I bet an 80 terabyte SSD will be a thing. And so that's a million times bigger. But how much bigger is data? How much bigger are applications? And how much faster are things? And all these other aspects. So we have to kind of think about, is it any bigger? Is the blast radius any worse? Because that goes right back to the core question here. Is the blast radius of a 60 petabyte server really worse than the blast radius of a 1 terabyte Novell server in 1995? Maybe, maybe not. Even though the numbers are different.
Right. It all starts with the workloads, right? So although the technology is a lot faster and the drives are a lot bigger, we have to realize that the demand for workloads has significantly increased such that the workloads are demanding a lot more relatively from your infrastructure than they ever had to be. For example, if you wanted to replace a hard drive, you have to rebuild a RAID block in the early days, the system would be down. Today, the workloads don't tolerate any system to be down. So this all has to happen.
Any right system today that needs to stop operation to rebuild the system? No. So it's actually, we totally agree. So that what is the value of your data? Okay, compared to 20 years ago, for example, it is the same. So you had in that hard drive 20 years ago all your valuable data. Now in the SSD, you are probably all your valuable data. We were talking yesterday about spending $9 per month on Apple to store your family photos. You didn't have, and nobody was there saying, "Oh, okay, we can find a solution to save money or whatever." In the end, it's the value, and you are taking so many pictures, but we are talking about 2 terabytes of photographs. My first camera probably had a few megabytes of total storage, and I didn't know where to put the photos. I was still thinking about taking photographs.
Right,
Okay.
but I think there's a big difference. The value of data is not storing the data. The value of data is processing the data. 15 years ago, people could store a lot of data. They just couldn't process that data because the only thing that was available to them was a single socket, single core. And in order to process that data, they could never do it.
I think you're getting at something very interesting. I love, by the way, Stephen, I love the idea of the inflation of data, and looking at what is it relative to, right? So architecturally, the architectural cost of data, not the business cost, the architectural cost of data, I think has to be, the only other, I guess, the dividend or whatever's underneath the fraction line has to be, I think, the speed of transmission within a system, whether it's PCI bus or network or however data is transmitted for either a rebuild process, for a production process, DR, right? And so the point I made before is that the density of data within the media is still moving faster than the increase of speed of networks that are generally available within systems and out and between systems, right? So it is costing more. It maybe not as much more as it would seem, but I still think it's a higher amount, and especially when you have to double it and triple it because of all the stuff we're doing and what Enrico was talking about, the expectations of service levels on this data, of more data that should be treated as tier 0. I think it does actually cost us more, and so blast radius does become a bigger issue.
Yeah. And I would say that I think that I haven't done the explicit math, but I have thought about this question. And I think that you're right. To answer my own question, I think that you're right that the blast radius is worse now simply because the speed of the interfaces haven't kept up with the growth of capacity. And the number of processor cores haven't kept up with the growth of I/O interface and the amount of memory and so on and so on and so on. Essentially, I think that our systems are objectively bigger today. And I think that that's driven by external factors and economics that have more to do with the vendors and the producers of those components and the limits of the system architecture than they do with the use of data. The reason that we have 128 core CPUs today is not because people want 128 core CPUs, but because that's the most efficient way for vendors to process cores into chips. The reason we have 60 terabyte SSDs is not because we can handle them, but because that's how much we can fit in there. And that's a good product.
But at the same time, the interfaces have changed. I mean, we were talking about comparing SAS to whatever. PCIe and NVMe interfaces can actually read and write these large capacity drives very quickly and are basically running at memory bus speed within your box. So you actually can do it.
But you can't. I did the math a few years ago on something that I called flush time, which was the amount, the length of time that it would take to read or write all of the data on a drive over the fastest speed that the interface could handle, and it actually is declining.
You remember when the storage was the bottleneck of everything? And actually, you know,
It's the other way now.
You mean today?
Well, it's the storage engineer's job to push the bottleneck up the stack, right? And they've done that apparently now.
Yeah.
Yeah, speaking from an ops perspective, it's funny that you mentioned that. Storage is no longer the bottleneck. It's the rest of the infrastructure. It's the apps, it's the devs, it's the CPUs, it's the memory, it's the networking, as you alluded to. I agree with you that the networking hasn't kept pace with as fast as we can read and write the data. And if you have the option to have the networking available to you that does that, it's very, very expensive. And today. Yeah.
Tomorrow it'll be cheaper.
Right. You know, we do have 25 gig is almost the standard now between, you know, your LAN systems. But when it comes to WAN, we're still sitting at 1 gig if you're lucky in some rural communities. We're still looking at different small business environments, or even, you know, some of the bottom Fortune 500 companies. They're not having all of that money dedicated to, you know, private internet access or direct internet access or express lanes from Microsoft and Azure and Amazon and Google.
But you talk about
all of that is distributed, but then it doesn't keep pace with, you know, 60 terabyte drives that fill up a 1U array, and you have, you know, 3 petabytes available.
But you talk about rural areas having 1 gig internet at this point. 12 years ago, 128K was the fastest that you could get in most rural areas. That would have been an ISDN speed. And I mean, that's increased tremendously.
40 times.
Yeah.
Okay.
Yeah. I mean, basically 10,000 times.
Oh, okay.
The challenge I have is that these bigger drives are great, and the networking speed, I think, is relatively decent. There's just so much data being created today that's not even being stored. I mean, I you know, when I look at the math, it's much less than 10% of the data that's going through the network today is actually ever stored.
Yeah, that's a good point.
Stored.
That's a real good point.
Right. And I mean, going back to Enrico's point about wanting to store, you know, loads of photos 10 years ago, the difference today is that you want to store loads of 4K video rather than loads of photos.
It's a good point. So I guess my point that I was trying to make is we first have to agree that there's a problem before we can talk about sort of what the problem is. I mean, do we agree that systems are bigger than they should have been, or bigger than even in adjusted ways?
It's in the old days, you'd never even try to back up a petabyte. You'd replicate it maybe, but you'd never try to back it up because it would be insane. These days, what are you doing with a 16 petabyte infrastructure? These guys are 3 petabytes per 2U. Okay, so in a 40U rack, we're talking, you know, lots of petabytes. Is that what are you going to do with all the data? I think if there's AI, ML stuff, makes a lot of sense in that space, but
back to the application piece, right? And how the data is being used, because all the data we have is sitting right on huge storage arrays. And yes, we have new data. Do we ever want to back it up? I don't know. How are we going to want to use it? And how are we want to extract it and make meaning out of the data? That's the only reason it gets stored.
the blast radius only makes sense if the data is important.
Well,
Right, so that's what I'm trying to say. So like, if you look at it from an application standpoint, or how you're going to use the data, this is what was already said. That's where you look at the blast radius, not how big the server is, or how big the storage array is, or how big the drive is. But I need to keep all the banking records for 7 years. That's
Guys,
important.
I think that the problem is different here. I mean, so it's that again we have, and maybe this is the classic wave that we see in IT is that there are bottlenecks again, and this time it's not storage. I mean, so the architecture is not balanced, not anymore.
But we're
This is
seeing, look,
why
we're seeing, we're,
there are all these. I mean, so CXL, for example, is here because there is an unbalanced system today. So you don't have enough RAM. I mean, you have too many cores, but actually you can process the data quickly enough. You can move the data quickly enough. Okay. So you want to have more local data, and in this case, is an extension of the PCI bus. I mean, which is just thinking about it. I am extending the PCI bus to grab some memory from somebody else, from somewhere else, to bring it logically into my system, and have a more balanced system. This is a little bit.
yeah, look, there's a whole industry of data service providers that are cropping up that we're seeing now in seismic, in healthcare, in financials that are providing information to other subscribers, and this is where the density of data we're going to see the largest thing. It's not like general enterprise stuff, but the amount of data being served out to multiple consumers that are being used for ML, where you can grab a whole raw data set that's being offered to these different consumers. This is where you're going to see this problem, I think, arise from a blast radius. They're the ones who are going to create the multiple petabyte, exabyte data sets that can be consumed that probably contain all of our personal data over the last 20 years, right? That it's being mined to essentially create zombies out of all of us. But this is where, and maybe from our perspective, we kind of want them to get all. This is so from that perspective, to have a rack go down that has 20 petabytes in that rack, that will have an impact not just on that data service provider's business, but all the consumers that are going to go and use that business, that they don't have that exact same data in another rack somewhere in a different region that can still be consumed, right? And obviously the cloud service providers are all going to have this problem, but at some point, from a data service provider perspective, it's more economical to have your own infrastructure for this, if you can OpEx it, right? But that's a different animal. The problem is, though, from that's where your blast radius issue that we're talking about, that I'm thinking about, is definitely going to become an issue, because you can't move that data fast enough over a network to bring up a new array. Like, how long is it going to take me to take 50 petabytes or 100 petabytes if I stand up a new array to get a copy of that data set over into my new region? It could be months before it's up.
Well, and I think we've all seen in this world of cloud outages too. You want to talk about blast radius, AWS US East.
Yeah.
There's a big blast radius to that boy.
Yeah. How many applications does that take down? How many services does that take down? How many things that people don't even know are in their own apps does that take down? Which has happened a few times, where there's other third-party libraries that they're using in their applications that tie to Amazon's availability zones. The availability zone goes down, and the app's like, I don't host this in Amazon. Why am I down? And they look in their code, and the third-party library that logs my logon page, Amazon.
Amazon gives you the answer to that, though.
Well, they do.
They do. The answer is take your app, make sure you're replicating it.
Yep.
and that's it. But it's that specific application, and you might be talking a couple of petabytes for bigger customers in the cloud. But actually, you got some very large backup providers in the cloud that have that. Think of how much data they got, exabytes up there, and who knows? Are they paying for the multiple regions? You'll never know until it goes down.
Well, and we're looking at this now from the perspective of how we see apps being used today. Think back 5 years ago about streaming, and did anybody really foresee that everyone essentially wants to cut their cable and just use streaming services if they can, right? So one of the things that really I see is prescriptive analytics going forward, right? And major companies, organizations, healthcare organizations, whatever it might be, making prescriptive analytic or machine learning AI decisions based on scads of data, petabytes worth of data that they do need to have available for their well-tuned and well-tested model, whatever that might be. Think of the entire air traffic control system going down simultaneously because of a cyber attack. Think because someone in Russia decides to have a nuclear attack.
Or because
right?
the runway floods and it
thank
takes
you.
everything down
Yeah.
for in Austin all the time.
No, yeah. Or right out here on the main approach for SFO, right? These are things that are going to happen, and the prescriptive analytics, right? These guys are going after gazillions of bits of data, and they're not all inside their own data center. Some are in the private cloud, some are in the public cloud, somewhere are who knows where, being reached from an API.
Probably an awful lot of them are derived, so they're not necessarily things that they're stored somewhere else. They're things that are actually calculated and derived.
Right, and it could be this bunch of JSON documents over here, this Oracle database here talking to something, a SQL Server database sitting in Azure.
It's a web of information.
Yeah.
The
interweb.
A worldwide web.
Worldwide web, almost.
What a great name.
I mean,
so it's going to be interesting to see in 5 years. It'd be nice if we could bookmark this discussion and go back to it and see how
I'm sure we
inaccurate
can, because I'm sure it's going to be saved somewhere.
Yep.
Yes.
And I mean, one of the things that's already happening are like oil companies or whatever are actually taking seismic data that was collected 20 years ago and analyzing it in more detail, since they have the capability to actually analyze it in more detail, and actually saying, oh, hey, there's a pocket of 5 barrels of oil we can go drill for or whatever.
So back to the topic of the blast radius of ever-increasing system components. Any final thoughts? David, we started with you. You want to have the final word?
I think it's a fascinating topic because the value of the data is increasing. The duration of the data is increasing. The amount of data that's getting discarded is decreasing. The amount of, really, the blast radius of a system component failure has much more collateral damage. To go back to the banking example, if that bank is down 20 years ago, you're like, yeah, okay, I'll come back tomorrow. Today, you're attacking every social media network you've got to say this is the worst bank ever. So it's the business impact of the collateral damage that I'm really, it's fascinating to watch.
Well, thank you very much for that. We will be continuing these discussions here at Storage Field Day. Watch the rest of our roundtable discussions by going to YouTube/TechFieldDay or the Storage Field Day 24 page at techfieldday.com.